In one of our previous videos working with Linux run levels, we talked about how the init process is the process that begins the entire set of processes for the Linux operating system. Not only is the init process available, but there are alternatives to init, especially systemd and Upstart are popular alternatives. And in this video, we're going to look at all three of those and how they operate and some of the differences between them. The init process has been around since the Unix days, since the System 5 configurations. It's part of the Linux standard base, the LSB. It is something that we've been working with for so many years, but there are newer versions that replace init, and we'll talk about systemd and Upstart later on in this video. The functions around init all start with a file called init tab. We're going to look at init tab. It's in the etc directory, and this has the information about what scripts we're going to run for each run level that you choose. So if you're going to run a run level 3, this is going to point your Linux machine to run the proper scripts for run level 3. If you're going to run level 5, it's a completely different set of scripts. We'll look at those scripts. They're contained in etc init.d, and there is an RC script that begins all of the other scripts that are in the init process. Every run level has an entire directory of scripts, and we're going to look at them. And you'll notice the scripts are named very specifically. Scripts that have an S at the beginning of them are used when we start that run level, and scripts that have a K in front of them are used when we kill or come out of that run level. Init is very specific on how it starts these processes. It does them in order, and it begins running one script. It waits until that script is finished, and then it proceeds to the next one. It does not run scripts simultaneously. Let's have a look at the files that are on our Linux system and how they're used during this init process. As we mentioned earlier, everything starts with the init process in the file init tab. That's going to tell us everything we need to know about what init will do next. So let's look at init tab. And in this file, there's a few things we can look at right at the top. The first one is the default run level. You can see run level ID 5 is init default. That's the run level that will operate by default. We can, of course, choose other run levels when we start our system. And if we do, you can see documented. It tells you what those run levels will be and what they will run. And these are the scripts right underneath it that shows when, for instance, you run a run level 5, it's going to run a script etc init.d rc with a parameter of 5. It's that particular script that starts all of the other scripts that are going to run for that run level. So let's have a look at those. Let's go into init.d. And if we look inside of that, there's a lot of files in here. The ones it's going to run, obviously, is that RC script, and then it's going to run the scripts that are in the rc5.d directory. And if we go into the rc5.d directory, you can see these are the scripts that will operate. And you can see they have a K at the beginning for when we stop that run level. The S is the one that is started when we start the run level. And you can see the names that make sense, things like running the network or the syslog, and they are numbered. So you'll see which one starts first and which one starts second. The init process doesn't know if any of these scripts depend on any of the others. So you're the one that has to administer this and make sure that the proper scripts are starting first and the proper scripts are starting after that one. So you have to be very familiar with all of those dependencies. When we start looking at Upstart and systemd, you'll notice that dependencies are already taken into account. But if you're managing a system that depends on init, you're the one that's going to have to make sure that the dependencies are in the proper order. Upstart is intended to be a replacement for init, and it is something that was developed for Ubuntu, and you can find it at upstart.ubuntu.com. A lot of advantages come with using Upstart. You have better support for USB-type hot plug devices and other types of hot plug devices. It's designed to have better and faster service management. We talked about some of the problems with being able to manage things like dependencies, and it works asynchronously, which means it can run multiple scripts simultaneously and get your system running that much faster. You'll find a lot of the configuration files for the Upstart initialization in the subdirectory etc/init. A lot of this is in progress, and you'll find as distributions progress that a number of the older scripts will be written to take advantage of the Upstart scripting process. The application that controls this process is called initctl. We're going to use initctl to control these Upstart processes and see what's running on our system. This is a CentOS distribution that's running Upstart. So let's have a look at some of the differences that we'll see when we look at this system versus one that was running the older Init. Now, if you recall, the Init tab was where we started with the Init. Let's see how that's different on an Upstart system. Let's look at Etsy and let's have a look at Init tab. You'll notice one of the first things at the very top of this file is that it tells you that it's only used by Upstart for the default run level. Adding other configuration here will have no effect on your system. So it's really leaving this in place for some of those more legacy applications that are looking for that Init tab. And then you've got information in here that really just has one line, which tells you that it's going to use the Init default. Otherwise, everything else that's running on the system is using that newer Upstart configuration. Let's look at some of those Upstart files. If we move into the Init directory, you can see there are a number of files in here, and it's things that you might think about for scripting your system. Things like the read-ahead collector, the serial configuration, the TTY configuration. You've got these Upstart scripts that are already available in this particular system to be able to run on your computer. If we were to look at one of them, let's have a look at the serial configuration. You could see that it is a little bit different than the scripts that you would find with something like the Init. Upstart is using some very different ways of identifying what should be started and what should be stopped, and then different parameters associated with those. It's these scripts that will have to be created or migrated from the older Init process to the Upstart process. And if you have scripts that you would like to run during startup, you might as well begin writing them for Upstart if that's the particular initialization that your distribution uses. To manage these Upstart scripts, we use an application called initctl, and I'm going to use initctl with the parameter of a list, and this will list out all of the processes that are managed by Upstart. And you can see a lot of these names are associated with the scripts that we were just looking at, things like read ahead and start TTY and the serial connections. And using that initctl, you can start that particular process or stop that particular process, and it's all managed from that Upstart application initctl. Another popular alternative to Init is systemd. You'll find systemd at freedesktop.org/wiki/software/systemd. This is designed to be a much more functional replacement for Init. It's certainly much faster, and it's designed to be very streamlined. You'll find that it handles dependencies quite nicely, and it's also designed to run multiple scripts simultaneously, get your system running that much faster. You'll find it in distributions like Fedora, OpenSUSE, Arch Linux is ones that the systemd is already a default. So when you install those distributions today, you'll find that systemd is what's running in the background. You'll find the systemd configuration files in the etsy/systemd directory, and we're going to use an application called systemctl to be able to manage those services. This is an OpenSUSE distribution that is running systemd. So let's have a look at what some of the differences might be. I'm going to first start in the Etsy directory, and let's look at Init tab. You can see it's one line, Init 3. This particular configuration is built to automatically start at run level 3 whenever I start the system. There's nothing else in the Init tab file other than that. Let's then look in the systemd directory then. There's a number of scripts in here. There's a system folder where we can start to see what some of those scripts might be. Things like the syslog service, for instance. And if we were looking at the syslog service, you can see that it's a relatively simple file, but it has a structure in here that shows the unit, the service, and the installation information. So it's very streamlined in how it operates. It's a standard structure, and you can apply this to any of the services that you'd like to run on your system. Let's now use systemctl to manage these services. If you simply type systemctl at the prompt, you'll see all of the services that are currently active and running on your computer. And as I page down, you can see there are quite a few that are running on here. Now, if you wanted to know about one particular service, you could always specify that at the command line with a systemctl status. And then, for instance, you might want to know about the ntp.service, and it gives you information about that service. You can see that it's the network time protocol daemon. It is loaded, it is inactive, and you can see the group associated with that. Now, we could start that service by also using the systemctl application. I'm going to start the ntp.service, and it just gives me a prompt back. But then I want to look at the status, and you can see it's very different now. We can see that it is loaded, it is active and running, and you can see the latest information about that particular service. You can see everything that happened when we started up that service and had it running. Gives us a nice feedback of what's going on there. So systemctl gives us a lot of flexibility. We can see everything that's running. We can start applications that aren't in our list. We can stop them. A very nice way to get all of those services managed from one central view. Now that you know about 3 of the most popular ways to start these processes on your Linux device, have a look at your distribution and see what your particular system is running. You may find that it's running Init or systemd or Upstart or perhaps another type of initialization, and that way you'll have a better understanding of how to manage the startup process and how to manage those services once your system's running.